So this is problem number 5, and in this problem number 5, they give you this expression, so I wrote it twice there. So the question is, what strategy should I be using? What I'm going to do the first time is, I'm going to change everything to sine, start with the left and right, and changing cot as cosine over sine, tan as sine over cos, cosecant as 1 over sine, and secant is 1 over cosine. So let's see what happens. The first one I'll write is cosine, so this will be cosine square of x over sine square of x. This tan is sine over cos, but because of the square, you put x over cosine square of x. The right side, this is 1 over sine, but because of the square, you put that, and this is 1 over, so that's the first step. Okay, now let's use, have a common denominator. There's a sine square, there's a cosine square, or you can just use the cross product this way. So this one multiplies here, this multiplies here, and this multiplies here. Kind of easy way to do if we have A over B plus C over D. This is same as A times D plus, so you multiply this, and B times C over, and then you multiply the down BD. So we're gonna use that right here. So this will be cosine square, so I'm gonna write cosine square of x, but you square that, and this sine square and this sine square will be sine square, but it is square. The denominator will be multiply sine square and times cosine square of x. Now, if in this case the same thing, you multiply this here, so this will be cosine square of x, and this will go right there. That's sine square of x. So this goes, okay, and the down will be okay. Now that you have this of the form a square, this is like a, the other one is the b. So what you do is a plus b, difference of square, the denominator stays the same, but this will be two parts, which is a, that is cosine square, the one with plus, the other one with minus, and sine square here. And the right side, just keep it as it is, don't do nothing. So this stays the same. But you see here with the Pythagorean formula, this thing will be 1. So we get directly cosine square of x. And this is the same thing. Okay, and you can see they are the same. So that's how you can prove. This is the easy way. But let's see if I want to use the other Pythagorean triplet. Suppose I wanted to start only with the left side without changing cotangent to sine and cos. Is there a way? Now cotangent by Pythagorean, check it out. 1 plus cot square is cosecant square, so we can always write this as cotangent square is cosecant square minus 1. Subtracting 1 both sides, this can be replaced by cosecant square theta minus 1. So that's because you subtract 1. And the other one is, this is minus tangent, you will replace by tan square, secant square minus 1. So tangent square is secant. So this is secant square x minus 1. Okay. And now open the distribute minus 1. So this changes. Open the parenthesis. This becomes. Oh, this is x. Sorry. And this will be secant square of x. minus minus plus. So this crosses out and you're left with cosecant square of x minus secant square of, and that's the right hand side, I can see that. But the question is, what if you want to do begin with the right hand side? So if I start with only the right hand side, then you have to change cosecant square to, because you want to get in the form of tan part, so we can write directly secant square and cosecant square can be replaced. So cosecant square is 1 plus cotangent square. And what is the meaning of secant square is 1 plus tan square of x. Yeah, I'm doing coming. So this will be 1 plus cot square. See? So this crosses off and you get cot square minus, which is the left hand side. The goal is to show both ways. One is you can do left right together, or you can start with the left side to get the right side, or you can start with the right side to get the left side. Hope that helped. That was problem number 5. So stay tuned to go to, let me check which one we are on. Yeah, that was problem number 6. So this one was problem number 6, and this is video number 4. So the next video I'm going to do 7, and I'll just build up all the identities. Thank you for watching.